Hello and welcome back to the channel. I am Sasleen Singh and we are back with a new video which is the 8 queen problem, and the programming language which we are using is Python and the IDE is Jupyter. This video will be containing all the phases from perceiving of the problem till the execution part. And let's jump right into the problem statement, which says the 8 queens puzzle is the problem of placing 8 chess queens on an 8 by 8 chessboard so that no two queens threaten or attack each other vertically, horizontally or diagonally. Before jumping into the perception part, let's see how do we pinpoint or name a square on the chessboard. Each square will have an alphanumeric code or value given to itself, as each file or column has an alphabetical value and each row has a numerical value. So if I want to pinpoint the G5 square as shown in the example, G being the alpha value and 5 being the numeric value. Now let's see what all data structures and things we use in our problem. And the thing is that we'll be actually denoting or finding out what kind of data structures which we'll be using. So we'll be using a stack to store the configurations, and set to store the explode nodes so that no two same configurations are pushed into the stack. So we've got a stack and an array of 8 numbers which will be denoting the files, and the all of these will be denoting the files from A to H. Let's just denote them. Okay, so we've got 8 files and these will be denoting the rows on which the queens are present. So we've got an array, a stack and a set. So these 3 data structures will be used throughout the program, and let's see how the configuration will look like. So suppose if I want to say that I've got a queen on A1, B3 and C5, the configuration will look like A1, B3, C5, and the rest of them will have zeros. Alright, and now let's jump to the part where we actually start solving our 8 queen problem. Now just for the sake of the argument, let's say that the user starts, or we'll actually prompt the user to choose a row from A1 to A8 to put the queen, and just for the sake of the argument, let's say the user chooses A1, then we'll have an expand function. Let's just draw some values and we'll use an expand function to expand the values. So we'll have 8 children of A1, which will be A1, A2, A3, let's just mark them, A1, B1, A1, B2, A1, B3, A1, B4 up to A1 and B8. Now we'll have another function called the check safe function, which will rule out any configurations which will have any conflictions horizontally, vertically or diagonally. So A1, B1 and A1, B2 will be ruled out because this has horizontal conflicting queens and this has diagonally conflicting queens, more or less like this. So A3 will be pushed into our stack, and so will the rest of these, and then we'll be popping out A1, B3 in the next iteration. So we'll have 8 children of A1, B3, and let's just mark those A1, B3, C1 up to A1, B3, C8, and then further we'll be applying the check safe function to all of these and pushing only those which are safe. So the check safe function will actually return boolean values, which is true if the function is safe or the position is safe, and false if the position is not safe. And if the position or the check safe function actually returns false, it will not be pushed into the stack, and if it is true, only then it will be pushed into the stack. So we'll be carrying out these till we get all the values from A to H. So we'll have the solution something more or less like 1, 3, 5, 7 and something, suppose 6 in this situation, right? So let's get back to our program and see what actually happens. So as you can see, this diagram actually denotes or shows how a conflicting position can occur, which is 2 queens on the same row or the same column and on the same diagonal. So these should be avoided, and these will not be added to our stack. So let's see what all we have used. We used 3 libraries: the time library to show or denote the execution time, IPython display, and chess libraries to display the boards such as this. Our solver function is actually the main function which follows the flow of the algorithm, and in this function we have been using different other sub functions, and which we'll be talking about them in later stage. Let's see how this actually happens. We've got a stack which we've talked about to store the configuration, a set stack to store the explode nodes. So what we'll be doing is we have the argument as board, which will be passed by the user, and which will be inserted into the stack, and then we'll be iterating till the stack is empty, in which case we'll print that there is no solution, or if there is a program or a configuration in the stack, we'll be popping it out and we'll be checking it, that is if there is a place on board to put a queen, and if there is no place, then we sure have reached the solution, and if there is space, we'll be expanding and having 8 children of that configuration. And finally we'll be checking that are those we'll be iterating through those children, that are they safe or not, and if they're safe, have they been explored before or not. So if they have not been explored before, we'll be pushing them into the stack, and then in the next iteration we'll be popping them out one by one. So let's see what other functions we've used. We have got another function called number 0, which actually returns the number 1 to 8 if there is an empty row, and if the board has 8 queens, it will return 0. We've also got a function called check safe, which is I suppose the longest function in the whole program. So it actually checks for queens in the same row and the diagonals. So we've got 2 kinds of diagonals, one which has a positive slope and one which has a negative slope. So we'll be using we'll be checking the program for 2 diagonals, which is diagonal 1 and diagonal 2. So we'll be checking them one by one. We've also got another sum function of check safe, which is check diagonal conflict excuse me, which has again 2 parameters, which is state and diagonal. So the state will actually be an array of the current state, and diagonal 2 will be an array containing configuration for each of the queens starting from A to H. So we'll be checking those, and if the check diagonal conflict returns false, we'll be returning false for the check safe function, and if it returns true, we'll return true. So we've got another function called the expand function, which allows us to create 8 children of a certain configuration. We've got another function called check diagonal conflict, which was the sub function of check safe, which actually allows us to check the conflicting arrays or conflicting queens on the diagonals, right? So this function or this part of code actually is where the execution really starts. So we've initialized a board which has no queens, denoted by 8 zeros, and then we prompt the user to add enter a number from 1 to 8 to start from the A file. So let's see if we can get an answer. So we get the current configuration as 1 and followed by 7 zeros. So we have a queen at A1. Then we'll be passing this to our solver function, which will find out that is there any viable solution for our queen at A1, and then we can have further 7 queens on the respective rows. So let's see, our function took 3.1 seconds and it has provided us with a solution 1, 5, 8, 6, 3, 7, 2 and 4. And now let's just put them in our chess library, and let's see that if we can see if it is viable or not. So we've got A1, B5, C8, D6, E3, F7, G2 and H4. And now let's just display those queens on our chessboard. So we've got 8 queens, and as you can see, we've got each queen on a file and each queen on a row, and they are not conflicting diagonally on any of the part. Okay, so we can run this with different configurations, and now let's just see if we can actually the computer can provide us a solution for A5. So we've got a queen at A5. I wanted to place queens on the other files, so we've got the solution. It just took 0.3 seconds. Let's see, we've got A5, B1, C4, D6, E8, F2, G7 and H3. Now let's see it on the board, and you can see that this is the solution. Now this function actually, this program or the algorithm actually uses backtracking, which is we start adding it from the lowest most part, and then if it doesn't actually help us out, then we'll be using the stack to pop the configuration which was used before, and then we can actually carry it on. So I hope you enjoyed and understood. Thank you and have a nice day.